All right, this is our volume notes video. So this was the first set of notes we did for the first day of volume. So you can see we have 5 different three-dimensional figures. We're going to start by talking about the formulas and then apply them with numbers on the backside. Unfortunately, you guys have to memorize these formulas because they are not provided to you on the EOC. So in class, we're going to memorize these. But there are some helpful ways to memorize them. So there's 3 facts we're going to talk about before we get into the formulas. So I'm putting 3 bullet points up here. In the first one, I'm going to say that volume is equal to base times height. And so just remembering this fact will kind of help you to be able to memorize these formulas. So it's equal to the area of our base times the height. And that's true for all of these, except a sphere. A sphere is just kind of its own deal. But for the rest of these, it's just base times height. Area of your base times your height. My second hint involves these ones with curvature where there's circles. So if we have circles involved, we know that the Greek letter pi is going to be involved. And so sometimes it's helpful to know the area of a circle because a lot of times that's our base. We're going to find the area of our base, the circle, and then multiply by the height. So an area, or the area of a circle, it's a circle, is equal to pi r squared, which you actually should have learned in the past, pi r squared. Okay, and then the last helpful hint I have is that if we have a pointy figure, it's like our cone and our pyramid are pointy, then the formula is going to start with 1/3, the fraction 1/3. So it's kind of a weird one, but I'm going to say pointy figures start with 1/3. Just kind of a helpful little hint there. And so we're going to try and discuss these in a way that conceptually makes sense so that we're not memorizing so much. We can just kind of make sense of the formulas. In this first one, you guys should know a prism. It's just a box. Sometimes it's a cube. And again, it's going to be base times height. More specifically, that's length times width times height. So volume is equal to length times width times height. And notice how I drew my L. This is really common in math to draw your L's like that. If I just did a lowercase l, you may confuse it for a 1. So we like to do it like this. You could use capital letters, I suppose, as well, but this is generally how we see it written. And another thing to mention is it's length, width, and height, not height. I hear a lot of students and adults say that, but the word is height. Okay, so this one you should definitely know from the past, so there's no need to memorize that one. We're going to move on to a cylinder. And so remember, we said volume is equal to base times height, the area of our base times our height. So in this case, the area of our base is a circle. Okay, and we know the formula for area of a circle is pi r squared, and then we just have to multiply by our height. So you can see how this is base times height. And I can kind of visualize this. I don't know if everyone can, but I picture, okay, if we're finding the area of the base and then multiplying by the height, it's kind of like we're filling up the figure, right? So that's kind of how I think about it. But that one is going to be pi r squared times height. Okay, for a cone, so there's kind of an interesting fact here about the relationship between cylinders and cones. So if we had a cylinder and a cone, and let's say they had the same height and the same radius, do you know how many cones it would take to make one cylinder? And some people will think 2, but it actually takes 3 of these cones to make one of those cylinders, as long as they have the same height and the same radius. So that's why when we start with the volume for these pointy figures, we start with 1/3, because a cone is literally 1/3 the volume of a cylinder. So it's going to be 1/3, and then I'm literally going to copy the formula for cylinder. So it's 1/3 that formula for cylinder. So as long as you know the formula for cylinder, which I don't think it was that tricky to get that down, we can easily find cone. We just put 1/3 out in front. Okay, for pyramid, pyramid is very related to a prism. So if we had a prism and a pyramid with the same height, length, and width, it would take 3 of these to make one of our prisms, as long as they had those same dimensions. So again, that's why we start with 1/3 with these pointy figures, because a prism is literally 1/3 the volume of a prism if they had the same dimensions. So I'm going to put 1/3 and then come grab my volume of a prism. Length times width times height. And I should say that this isn't true for every pointy figure. They don't all start with 1/3, but these 2 that we are having to memorize will start with 1/3. All right, so these 4 I feel like are pretty straightforward. I don't think a lot of memorization is required. We can kind of make sense of each of these formulas, hopefully. And the prism you should have just already known from your past, maybe 6th grade. However, sphere is just kind of one of those weird ones where we are actually just going to memorize it. There's no easy way to derive it, or there's no easy tricks or hints, so we're just going to memorize that the volume is equal to 4/3 pi r cubed, right, to the 3rd power. So everything else we've been talking about it to the 2nd power. This one's actually to the 3rd power, so 4/3 pi r cubed. So I just say 4/3 pi r cubed. And I find the more you say it, the easier it will be to memorize eventually. So on our test, you will have to memorize these. Okay, on the back side, we're going to actually apply the formulas, and we have numbers back here. So for number 1, okay, well, first of all, we have to identify what kind of shape are we dealing with. For number 1, this is a pyramid, okay? So we're going to write down our formula. Well, it's pointy, so I know it's going to start with 1/3. And this is just 1/3 the volume of a prism, right? We said that, so 1/3 length times width times height. Some other things to kind of help you along the way here. If you're putting pi into your formula, we know it's not right because pi is only involved for circles. So we know pi is not going to be involved. So you just kind of want to make sure that you're being reasonable when you're writing down your volume formula, when you're trying to recall it. Okay, so we got to figure out what is length, what is width, what is height. Well, height is going to be this 6 right here, because height is your vertical distance on these figures. Length and width, it actually doesn't matter what you assign to each. You can make this length or width, this length or width. Even if one of these were longer, I mean, sometimes we think of length as being the longer dimension, but it really doesn't have to be that way. You can assign it whatever you want. Okay, so we have 1/3. I'm going to plug in our values. So length is 8, width is 8, height is 6. Okay. And so you could plug it like this in the calculator, making sure to put parentheses around your 1/3. What I like to do, though, is save the fraction for last, because I know multiplying by 1/3 is the same thing as dividing by 3. So I'm going to start in my calculator by doing 8 times 8 times 6. So I got 8 times 8 times 6, and that gives me 384. And now I'm going to divide by 3 because that's the same thing as multiplying by 1/3. I'm going to take the 384 I just got from multiplying these and divide by 3, and we get 128. And I'm just using my phone calculator because I didn't bring a calculator home, but it's much easier to do this in the calculators at school. So I'm going to put a unit on this. Our unit is yards, and since we're talking about volume, it's going to be yards cubed. So for all volume problems, it's our unit cubed, and that's because we're talking about three-dimensional figures, right? These are 3D. If we were talking about 2D, like area, we would put a 2. If we were talking about one-dimensional, like a line, it has an exponent of 1. That's why we don't see the exponent. Okay, so 128 yards cubed is our final answer. We're going to keep moving along here. So for number 2, we have a cylinder. And I'm remembering my formula for volume. It's base times height. Our base is a circle, so that's pi r squared times height. And obviously you can check the front side of our paper because we have all of our formulas there. But you want to kind of try and make sense of these so you're not memorizing it. Okay, so in this case, our radius is 4, our height is 12. I think those are pretty obvious, so we're going to go ahead and plug those in. So pi radius squared times height, oops, I'm plugging in h, I forgot, times 12. Okay, and so we're going to leave our answers in terms of pi, and it says it right here, leave your answer in terms of pi when necessary. So that means pi is actually going to be part of our answer. So I'm not going to hit the pi button on my calculator. I'm not going to type in 3.14 into my calculator. We're just going to ignore it for now, and then at the end, we're going to reattach it. So in my calculator, I'm just going to do 4 squared times 12. So let's see, 4 squared times 12, that gets me 192. So it's 192, and then now I'm going to reattach pi. 192 pi. And in this case, our unit is going to be meters cubed. Pretty straightforward. Okay, for number 3, we have a cone. And we know cones have the same formula as a cylinder, but it's a pointy one, so we got to put 1/3 out in front. So it's 1/3 pi r squared times height. All right, our radius is 11, our height is 22, so I'm just going to plug those values right in. And I tend to put a lot of parentheses when I'm plugging in. That just helps me compartmentalize what's going on. So that way radius squared has its own little compartment, height has its own compartment. But if you don't want the parentheses, it won't actually change the problem. So we know I'm going to ignore pi for now until the end. I have this 1/3 out in front. I'm going to leave that until later because I know I want to end up dividing by 3. So I'm going to start by doing 11 squared times 22 in the calculator. So our first step we're going to do in the calculator is 11 squared times 22. So go ahead and do that. 11 squared times 22, and that gets us 2,662. Okay, so now I'm going to go ahead and take that value and divide by 3 because multiplying by 1/3, that's the same thing as dividing by 3. And that gives us this decimal 887.3 repeating. I'm just going to go to the nearest tenth, so 887.3. And then now we will reattach pi. And then I'm going to do feet cubed. And so I've had a lot of students ask me why we're leaving this in terms of pi, because we could easily multiply by pi in our calculator and get a different correct answer. It wouldn't be wrong to multiply by pi in your calculator. This is just good practice because a lot of times on the ACT, SAT, your EOCs, standardized tests, they like to leave it in terms of pi. This is a really common way to see your answers. All right, my camera's being weird there. Okay, I'm going to move on to number 4. We have a sphere. This is just a volume we're going to memorize. It's 4/3 pi r cubed. 4/3 pi r cubed. That's one we just got to memorize. So our radius, a lot of people are going to think it's 12, but 12 is actually the diameter. We just need the radius. We're going to have to cut that in half, right? The radius is 6. And that's all we need for a sphere. We just got to plug in the radius. So I'm going to plug in this 6 cubed. Okay, so we're going to ignore pi again. I'm going to start by doing 6 cubed in my calculator. So 6 times 6 times 6. That gets us 216. Now you could just put 4/3 in parentheses and that's fine, but I know multiplying by 4/3 is the same thing as multiplying by 4 and then dividing by 3. So I'm going to do that. I'm going to do times 4 equals divided by 3 equals, and we get 288. And then I'll go ahead and reattach pi. So 288 pi, and then our unit is centimeters cubed. Okay, so these first 4 I think are pretty easy. You just have to know the formula. 5 and 6 require a little bit of thinking, so let's go ahead and look at this. I did kind of make a typo on number 5. I meant to give you guys the height, so we're just going to add that in right now before we get started. Just pretend like that was always there. Okay, so it says the following cylinder has a diameter of 8 centimeters. Okay, so right away I know none of our formulas actually use diameter, it uses radius. So if our diameter is 8 centimeters, I know the radius is half of that, so the radius is 4. So I'm going to add that in right now. Okay, so it says find the volume of the region inside the cylinder that is not shaded. Well, the cone is shaded, so we want everything that's inside the cylinder but not part of the cone. So kind of this white space around the cone. And there's some different ways we can think about this. I think the most common way is people think, okay, the volume is going to be equal to the volume of the whole cylinder minus the cone, because we don't want to include the volume of that cone. So most people will think volume is equal to cylinder minus cone, and that's how we're going to do it. But I want to mention the other ways that a lot of students have come up with. So some students remember the relationship between a cone and a cylinder. Remember, a cone is equal to 1/3 the volume of a cylinder. So if the cone is taking up 1/3 of the space around it has to be 2/3. So we could do 2/3 times our cylinder, and that would get us the answer. I even had one student come up with a different way where we find the volume of the cone, which is 1/3 the volume, and we multiplied by 2, and that would also give us the space around it. So there's a lot of different ways we can. Okay, so I'm going to go ahead and start by filling in my formulas for volume of a cylinder and cone. I know cylinder is pi r squared times height, and I know cone is the same thing with 1/3 out in front. 1/3 pi r squared times height. Okay, we know r is 4, h is 10. So I'm going to go ahead and plug in those values. And that's when this starts to look a little crazy, but keep in mind we're just subbing in the values that we know. Okay, so now it's pi 4 squared times 10. And again, I'm just replacing all of my r's with a 4 and all of my h's with a 10. Yes, I am adding in some parentheses, but that's just me. You don't actually have to, I suppose. Okay, so now I'm just going to work on each piece separately, keep this nice and simple. So for this first piece, we're going to ignore pi for now. We're just going to put in 4 squared times 10 into our calculator. Okay, and so when you do that, you should be getting 160. We're going to go ahead and reattach pi. Okay, so now our first little piece is done. Now we got to figure out this piece. So I'm going to start by doing 4 squared times 10. We just said that's 160. And now I got to divide by 3. 160 divided by 3 gives me 53.3, and then I reattach pi. Okay, now we have like terms because they both have pi, so we can just subtract these. 160 minus this 53.3 gives me 106.7, and then I can reattach pi, and my unit is going to be centimeters cubed. Okay, we just have one more problem down here. Kind of have this like snow cone looking thing over here. So it says half a sphere is attached to a cone as shown. We want to find the entire volume. So most of my students found that this is half of a sphere, and we got to add that to a cone, and we're adding because we want the volume of this piece plus this piece, right? There's no reason to subtract. Here we had a reason to subtract because we didn't want to include the cone. We want to take that away, so we had to subtract. Here it makes sense to add. So we're going to do volume of half a sphere, so half times sphere plus cone. And I'm just going to go ahead and plug my formulas in again. So 1/2 times my formula for sphere, well that's 4/3 pi r cubed, plus my formula for a cone, that's 1/3 pi r squared times height. Okay, and they give us our radius, it's 9. They give us our height, it's 14. So we're going to plug in those values. And then also, this kind of catches my eye right here. These fractions we're multiplying. So remember, if we're multiplying fractions, we just multiply right across, right? Top times top, bottom times bottom. So 1/2 times 4/3, well, that's going to give us 1 times 4 over 2 times 3. So I'm going to leave that instead, and now I'm going to plug in my radius and my height. Okay, so it'll be, let's see, 9 cubed plus, I'm just plugging in my variables, and I'll admit it starts to look a little crazy right now, but we're just going to treat each piece separately. So we're just going to focus on this piece right here first. So I'm going to ignore pi, but I'm going to start by doing 9 to the 3rd power. And it gives us 729. Now multiplying by 4, 6, that's the same thing as doing times 4 divided by 6. Okay, so 46, and then I'll reattach pi. Now I got to take care of this piece over here. So I'm going to start by doing 9 squared times 14. So 9 squared times 14 gets us 1,134. I need to multiply by 1/3. I know that's the same thing as dividing by 3. So we get 378. And then I need to attach pi. Now we can go ahead and add these together. 486 plus 378, that gets us 864. I'm going to attach pi, and our unit is inches cubed. Right when my camera cuts out.